This is part 2, all about what we did in the last video, chapter 3, section 4, exponential and logarithmic equations, but now part 2, both sides don't have an exponential expression, only one side has an exponential expression. So it's going to work the same way though, and I know in this case, for example, I'm going to need to take the log of 13, which I could use like base 13 maybe, but then I have to deal with log base 4 of 13. It's just weird. When these happen, I honestly use natural log every single time because it's easy on my calculator. You could do log base 10 if you really wanted to, but that uses more pen, so don't want that. I'm going to do the natural log of both sides. I can take the natural log of any positive number. Not zero, not negatives. Decimals are fine as long as they are positive. This is going to work just like my equations did before with this rule up at the top, where if I have an exponent in the logarithm, it can be multiplied outside of the logarithm. So over here, I'm left with x times the natural log of 4 equals the natural log of 13. I divide by the natural log of 4, and I get x equals the natural log of 13 over the natural log of 4. Easy on my calculator. So I get natural log 13, close that parenthesis before you click divide, natural log of 4. 1.85. There we go. We do another one. This one, the natural log works really well because it's a base of e. If I do the natural log to both sides, the exponent 4 minus 3x is multiplied out front, ln of e equals ln of 6. But ln of e is just 1, so that is nice. It's just 1. I don't even need to distribute anything. So I have 4 minus 3x equals natural log of 6. I'm going to subtract that 4. Now, this natural log of 6 is locked together. That subtracting 4 is outside of it. So don't write natural log of 2. The 6 and the 4 are not compatible like that. So I'm natural log of 6 minus 4 divide by negative 3. So I have x is equal to natural log of 6 minus 4 over negative 3. Easy for my calculator. Again, make sure you close those parentheses. Parenthesis for the numerator, natural log of 6, close that parenthesis, minus 4. Close the numerator, parenthesis, divided by negative 3, go. And I have a lovely 0.736. There we go. Last example, not very different than this example, but what I wanted you to see in this one, why it's specifically shown here, is that there's stuff on the exponent. For this one, for all the ones we did on the other example problems, there was nothing with the exponent, base, and the exponent. So this one does. It has a negative 2 and a 5. I need to get rid of those before I deal with the exponent. Remember, this is just multiplying here. The exponent of x in this case is only touching the e. It is not affecting the negative 2 at all. So what I'm going to do is first subtract that 5 and divide by negative 2. IB to the x equals 3. And we could keep solving from there very easily. We just take the natural log of both sides, and really, natural log and e, they cancel. I'm left with just x is equal to the natural log of 3. How nice. Therefore, natural log 3, I get 1.0986. So we'll go with 1.099. There we go. Alrighty. So that is all about what happens when I only have one exponential expression on one side of the equation. Nothing much is different. Stay tuned for part 3 of this lesson. This is all what we did on Friday, January 20th in class. The next video will be a homework page for you, and if you keep watching, the answer solutions for that as well. I did not collect that in class, but we did go over it, so you'll need that for your quiz, which is coming up at the end of the following week. So, there you have it. If you have any questions, please let me know.